Like any great performance, flying an instrument approach requires solid preparation, a dress rehearsal, so to speak. The problem is when you're transitioning from en route to actually flying the approach, you can get really busy and you won't have time to absorb the detailed information that you need for the approach. So self-briefing the approach while you're still some distance out from your destination is your dress rehearsal. It will keep you ahead of your airplane, reduce your workload, and make your approach go smoothly and safely. The key to a good self-briefing is to develop a systematic pattern for looking over the approach plate. Let's assume that your destination is the Albert J. Ellis Airport at Jacksonville, North Carolina. Based on the most recent weather report, you're expecting to use the ILS Runway 5 approach. So the first thing you want to do is make sure that you've got the right approach chart for the right airport. And we can see here at the top of the approach plate that we do have the approach for Jacksonville Ellis Airport, and it's the ILS Runway 5. Then take a look to see if any special equipment is required, like DME or ADF. DME is not required for this approach. If it had been, the approach would have been titled ILS DME Runway 5. But here's a note in the plan view telling you that ADF is required. And we'll find out why as we review the approach chart. Next, check out the communications frequencies. You'll probably be talking to Wilmington Approach Control on 121.4, although the star means that that facility doesn't operate 24 hours a day. And the Common Traffic Advisory frequency you'll use to announce your position at the airport is 123.0. The L in the black circle tells you you'll use that frequency to control the airport lights. Now, here's a real help. You can listen to the AWOS frequency of 124.475 and get the latest weather for the airport. Now, let's check out the basic layout of the approach. The localizer frequency is 108.7, and its identifier is IOAJ. And you know there's DME information available on the localizer frequency because there's a channel number in the ID box. Now, the localizer course is 052 degrees. There's an NDB at the outer marker. That makes it a locator outer marker, or LOM. Its name is Ellis. Its frequency is 261 and its identifier is OA. There's a middle marker just before you reach the runway. Now let's take a look at the minimum safe altitude, or MSA circle, and see what fix it's centered on and what the minimum altitude is in each sector. On this approach, the MSA circle is centered on the locator outer marker. You know that because that's the symbol inside the MSA circle, and the identifier OA is above the circle. The MSA altitude is 3,100 feet in all directions. Next, you need to consider how you're going to get to the airport from your present position. You want to conjure up a mental image of which way you'll turn and what minimum altitudes you'll fly. For example, if you arrive on one of the feeder routes from Wallow, Beulah, or Grove, you'd simply fly direct to Ellis at 2,100 feet, or whatever higher altitude the controller has assigned you. Of course, you can see that if you do start the approach by flying directly to Ellis, you'll need to fly outbound, then reverse course with a procedure turn. On the other hand, if you start the approach from either the Helena or Gala initial approach fixes, the routes give you headings to intercept the localizer inbound to the airport. You'd already be pointed in the right general direction to fly the approach, and the notes tell you not to make a procedure turn. But the easiest and most likely way to end up inbound on the localizer is for the approach controller to vector you to the final approach course. However you get there, you'll end up tracking the localizer inbound to Ellis at 2,100 feet. Moving to the profile view, you'll find that the minimum altitude in the procedure turn is 2,100 feet, and you maintain 2,100 feet until you intercept the glide slope. On an ILS, the point where you intercept the glide slope is identified by the lightning bolt symbol, and it's the final approach fix. On the other hand, if you lose the glide slope signal, you would fly this approach as a localizer-only approach. And this Maltese cross at the LOM identifies the final approach fix for the localizer-only approach. So if you were flying this approach without the glide slope, when you crossed the final approach fix, you'd start timing to determine your missed approach point. You can look in the lower right corner of the approach chart to check out the localizer-only missed approach point and times. The distance is 6 miles, and at 90 knots, the missed approach point would be 4 minutes past Ellis. We'll talk more about localizer approaches later. The altitude printed on the vertical line here at the LOM, 2080, lets you check the accuracy of both your glide slope receiver and your altimeter. If you're on glide slope and your glide slope receiver is working properly and your altimeter is correctly set to the local altimeter setting and working okay, then your altimeter will read 2,080 feet MSL when you cross Ellis. On an ILS, your missed approach point is not a place, but an altitude. It's the decision height as you fly the glide slope. It's called the decision height because when you get there, you must decide very promptly if you can land or if you must execute the missed approach. If you look in the minimum section on this chart, you can see that for the straight-in ILS to runway 5, ILS 5, the decision height is 290 feet, which puts you 200 feet above the runway 5 touchdown zone. And you must have flight visibility of 1/2 mile or better before you can land. If you lose the glide slope signal, you are now flying a localizer approach, and your minimum descent altitude will be 460 feet, but the required visibility will remain 1/2 mile. When you're looking at the minimums, you'll want to think about how the reported weather relates to the approach minimums and whether the approach will let you get in. And if you're aware of any approach components that are not working, such as the approach lights, this is also the time to consider how that will affect the minimums for the approach. Now, take a look at what to do if, when you get to decision height, you can't see the runway environment. The missed approach instructions tell you to first climb to 500 feet and then make a climbing left turn to 2,100 feet. You then fly direct to the Ellis locator outer marker and hold. And that's why you need an ADF receiver to fly this approach, so you can track to the compass locator and hold there if you make a missed approach. This is a good time to think about how you'd enter the holding pattern at Ellis. Notice it's a non-standard left-hand holding pattern. You'll be approaching from the north and will have to turn right to stay in the protected airspace. Normally, on a standard holding pattern, a right turn would tell you to make a teardrop entry. But because this is a non-standard left-hand holding pattern, the entries are swapped. The simplest way to stay in the area is with a parallel entry. Now, if you do have to make a missed approach, you'll be busy. So you want to memorize the very first action and altitude. Climb straight ahead to 500 feet. Now let's move over to the airport diagram and take a look at what you'll find at the airport. In this case, you can see that the runway is 7,100 feet long and 150 feet wide. That's a nice wide runway. It's also handy to note that all the taxiways are on the southeast side of the runway. That'll mean a right turn off the runway after landing. The note on the approach end of the runway tells you again the direction and distance from the final approach fix to the missed approach point, 052 degrees and 6 nautical miles. Notice also the touchdown zone elevation is 90 feet. And the rotating beacon actually is an obstruction at 155 feet of elevation. Now let's take a look at the lighting help you can expect. The A5 at the approach end of the runway 5 lets you know that an MALSR, medium intensity approach light system with runway alignment indicator lights, is installed. So you'd expect to see about a 1/4 mile long set of lights. And the dot at the top of the circle tells you the lights have a sequenced flasher. And no, I didn't memorize that lighting information. I looked it up, just like you can, on page L1 in the front of the Terminal Procedures book. Because the approach light symbol is shown in white type in a black circle, you know the lights are controlled by you, the pilot. And as we discussed, the frequency you'll control them on is shown up here in the plan view with the white L in the black oval. It's the CTAF 123.0. Now take a look at the end of the runway. The P here means that runway 5 also has a precision approach path indicator, or PAPI, that will come on when you turn on the approach lights. And runway 5 has MIRL, medium intensity runway edge lights, not high intensity lights. And again, they're controlled by the pilot. Let's check the notes under the minimum section. The first note says circling not authorized southeast of runway 523. So if I end up needing to circle to land on runway 23, I know I'll need to circle to the west and north. That would put me on a right downwind for runway 23. As you remember, the T in the upside down black triangle tells me that the airport has a departure procedure, or non-standard takeoff minimums for commercial operators, or both. Obviously, you can't memorize every detail on the approach plate. There's just too much information. But the 3 critical items you need to memorize from your approach self-briefing are: how low can I go? On this approach, the decision height is 290 feet. How far can I go? I can go until I reach that 290 feet on the glide slope, because my decision height on an ILS is also my missed approach point. And finally, which way do I go on a missed approach? I first climb straight ahead to 500 feet. Put the approach chart where you can see it easily, so you can refer to it as you set up your radios and fly the approach. Then review the VFR chart for your destination. You want to know where the airport is relative to the town, where any significant landmarks like lakes or rivers are located, and if there are other airports nearby. Then fold the chart so the airport area is visible. When you break out of the clouds, that VFR chart might be very helpful in making sure you land at the right airport. Newer Jeppesen approach charts have a feature designed to make your approach briefing go much easier. Jeppesen arranges the most important information you need for the approach in a briefing strip across the top of the chart. The information is in the order that you'll use it, which makes it easy to find when you need it in a hurry. Regardless of whether you use a Jeppesen chart or an NOS chart, the key to a good approach briefing is to have a systematic procedure that you use every time to find out in advance the information you need to fly the approach safely. Visualizing in advance what you'll be doing helps you anticipate what happens next on every step of the approach. It's called staying ahead of the airplane. It makes flying the approach a whole lot easier and a whole lot safer, too.